Thank you. Thanks, Lisa. Appreciate that. So I'll be talking today about what we discovered in our journey to estimate statewide pedestrian and bicycle miles traveled for the state of Washington. And I was working with a graduate student at the time, Mike Sellinger, who was in the Masters of Urban Planning at the time and is now working for Alta. And he may be able to speak at the very end if people have questions, if he's available. And I want to thank the National Institute of Transportation and Communities for their funding for this part of the work, and also Washington DOT, who funded earlier stages of the work and is continuing to fund this important research. And I want to thank my partners at Portland State and also my partners at University of North Carolina Highway Safety Research Center, where I'm currently working, and the folks at the Pedestrian and Bicycle Information Center. And we also have Taylor Phillips, who helped out at the part of this project as when she was a student. So I'll start with the purpose of why we want to understand cycling and walking on the state level, and then get into what we can learn from motor vehicle counting and estimation of vehicle miles traveled. Then we'll get into what we actually did in this study, and then the results, and then some generalized conclusions for what we can learn going forward and recommendations for what we should do in the future. So the purpose of walking and biking, all of you on this webinar, I'm sure, already have good reasons for measuring cycling and walking, but I want to go through and talk about the different levels at which we need to understand these metrics. So for funding and policy decisions, we really want to understand what's going on both at the facility level and the city level and the state level, because we want to understand, do we have change over time? Do we see increasing or decreasing cycling and walking? What does that mean? And then on the facility design level, we really need to know on this bike lane, on this bike path, on this sidewalk, how many people are using it, when are they using it, in order to do good and appropriate design. And then for economic impact, we need multiple levels. Health impact, maybe more on the larger level, but also we need to know. And then safety, we really need all levels. So for different questions and different purposes, we need to know different levels of where people are cycling and walking. And this research focused on the state level, but did not forget that we also need to know what's going on the facility level for these other purposes. So we'll just keep that in mind as we go through. So on the state level, I'm going to be using these two acronyms, bicycle miles traveled and pedestrian miles traveled. So let's go back. Some of you are very, very, very familiar with motor vehicle traffic monitoring, but I want to do a quick review so that everyone on the webinar is on the same page and what we can learn from this for biking and walking. So on the state traffic monitoring, this is how we get the vehicle miles traveled numbers that are aggregated and used to start allocating money from the federal government highway trust fund to the states. This has traditionally been used as, okay, states with more vehicle miles traveled may be receiving more funding from the federal. So permanent counters are used because we want to know how many people are using the road, how many vehicles are driving on the road, and that would be great if we could put permanent counters everywhere and know every road segment how many people are using that road, or how many, in this case, cars or trucks are using that road. Unfortunately, it's very expensive to put these in, so the state DOTs use short duration counters, which are usually pneumatic tubes, rubber hoses, to count on all these segments where they can't afford to put the permanent counters. And they rotate those. They don't necessarily do each one each year. Okay, so our permanent counters in the state of Washington, you can see that a lot of locations we do not have permanent counters for motor vehicles. But at all the locations where we do, we can very easily compute the annual average daily traffic by taking the total counts for that year and dividing by 365 to get an estimate of the annual average daily traffic. And from that, if we knew it everywhere, we could then estimate the vehicle miles traveled and we'd be done. But of course, we can't know that at the short duration count locations because we only have 48 hours or 24 hours at those motor vehicle count locations. So what do? We create an estimation procedure based on the season, the time of the day of the week. We create these factors at the permanent count site, we apply them to the short duration count site, and we then extrapolate up to annual average daily traffic at all those short duration count sites. And then, since we now have estimates across the entire network on every segment, or basically every segment, we can know the vehicle miles traveled by simply multiplying by the length of the segment and summing over the entire network. So that's the basic concept. Can we apply this method for biking and walking? I'm going to start with some acronyms here. Annual average daily bicycle traffic, and I believe this is the official FHWA, Federal Highway Administration acronym. Annual average daily pedestrian traffic, AADP. Okay, and if that weren't enough, we now have annual average daily non-motorized traffic. Okay, so I'm not going to use that last one, but we'll stick to the AADBT and the AADPT. Doesn't really roll off the tongue, but I'm working on it. Okay, so data that we have available. So in 2012, when we started this study, Mike and I looked, and all we could find was one permanent count site for biking, actually for bicycling only, not walking, for bicycling only, in the entire state of Washington. So one of our first things we did is we told the state, we wrote a memo saying they could probably put in some more. And unbelievably, they listened to us and they put in more counters. So it's very exciting. And now I just checked, these are the sites all over the state that now have permanent bicycle and pedestrian counters, and all those red dots indicate places where they're counting bicycles and pedestrians separately. So this is great news for future research. When we did this study, however, we were stuck with the 2012 data at one site. And then short duration count sites. The state runs a volunteer-based count program and in 300 locations, cities around the state, 300 locations, sorry, around the state, and these are just a sprinkling around the state. So you can see they've got pretty good spatial diversity for a short duration statewide program. But these are counting 2 hours and 4 hours. Sometimes they count morning and evening at the same site, and usually on a day in September or October. So our one site is in Seattle. It's on a bridge. It has a nice little display right there, and that is on the Fremont Bridge. And we have a nice commute pattern here with people going in the morning on the weekdays and then coming back in the evening around 5 p.m. Very clear commute pattern, and then not as many people on the weekends. Clear commute pattern. Now, is this appropriate to look at for the entire state? Let's think about that. We have 2,461 annual average daily bicycle traffic on this bridge, which is great. That's relatively high. Nice numbers to work with. And again, more during the week than during the weekends, and higher in the summer than the winter. Very seasonal here, higher in the summer than the winter. Should we apply this across the state? Let's keep thinking about that. I don't think so. And why not? Let's go back here. Because the state is very different. We have lots of different weather patterns across the state. We have lots of different events going on around the state. Not everybody is commuting to work. There are recreational patterns. There are patterns for people going to school. So this pattern that we're seeing in Seattle may not apply, and probably doesn't apply across the state. Okay, so factoring method that we're using to extrapolate our short duration counts. Remember, we've got 2-hour counts, and we want to get to annual average daily bicycle traffic and pedestrian traffic. So What we'd like to do is know the variation by month, and that would require us to know what's going on a continuous count station in the region that we're studying. And then daily and hourly factors. So we're going to take that 1 hour period that when the count is taken, divide it by the monthly average daily traffic. This is just a standard equation from the traffic monitoring guide. So here's an example for the month of December. We have only 1,000 on average per day at the site on the Fremont Bridge, but on average we have more like 2,000, so that's a factor of 2, meaning that December is half the counts of the rest of the year. So we came up with factors, and you can see here's December at 2. April is about average, so that's 1. And when we usually do the counts in September and October, when they do the manual counts, that's also around 1. So that's nice that they're choosing a representative month, but still good to adjust for weather activity. Now this is the daily conversion from from hourly to month. So here we took the for 7 a.m. to 8 a.m. for example, for the month of June on a weekday, divided by the monthly average daily traffic there. Okay, so again, should these now be, these are only based, remember, on our one site in Seattle. Should those be applied across the state? No. But that's the data we have. So non-motorized data, other data that were available, maybe there's some other data sources we could use. So we looked at those and we found there were travel survey data, but the problem was not that we did have a representative sample, but we can't get facility level information on that. So if we want to understand what's going on this bike lane, that is not going to get us the answer. The GPS data, so this would be maybe from an app on your phone, or there are many other ways to collect this, but usually it's from an app on the phone. So that's great, but again, there's a self-selection bias here. So we can't use that to necessarily represent all users on the road or path or sidewalk, and it's more used by cyclists than pedestrians. Okay, and then continuous and short-term counts, we've talked about those. We need additional data there. And then spatial variables, we do know what type of road it is or path. We know the land use around it, is it urban or rural? And we know the basic geography. So that's good. We have a good idea of that. And then the socio-demographics and the population. So if we combine some of these, can we get a better estimate? So here are the methods we decided to explore. We decided to explore 3 methods, try to triangulate on the problem. So we explored the sample-based approach, which is taking that VMT method I discussed at the beginning for motor vehicles and applying that directly to bicycling and walking. The aggregate demand model is a common approach for how we deal with these types of problems in cities, especially for pedestrians. So we're going to take all those socio-demographic and geographic variables and create a statistical model and then estimate it that way. And then the travel survey approach. This was really kind of a back-of-the-envelope approach because we do not have detailed travel survey data across the state of Washington. So this was just to compare national data to what's going on to see if we're in the right ballpark. So both of the first 2 methods I talked about rely on the annual average daily bicycle traffic, the ADBT and the AADPT numbers, the count data. They both rely on the count data in order to come up with estimates. In the first case, we're just multiplying by the segment length, and then the second case, we're using that socio-demographic data to come up with the estimates. The sample-based method, it assumes that we have a stratified random sample. Now, were our short duration counts collected at randomly selected locations? Unfortunately not. They were selected for specific reasons, which is also valid, but not applicable for this method. So it was local volunteers and coordinators who were selecting these count sites for volunteers to go out and count. And they were not selected randomly. So that's going to be an issue. And if we do a stratified random sample, as I'm suggesting here, what are the strata that we want to use? So we thought about that, and we looked at the research on what impact bicycling and walking, and we came up with 3 main strata that work for both bicycle and pedestrian volumes. So the first was urban versus rural, level of urbanism. So that's 2 strata. We considered looking at suburban, but found it very difficult to come up with a standard definition for that. So we left it at urban versus rural. We looked at different facility types, so arterial and highway and roadways, and then local roads and collectors, and then we realized first we lumped the trails in with the local roads and collectors, but when we actually looked at the data, we found a big difference between the volumes on the trails, which were very high where they were being counted, and the volumes on the local roads. So we separated those out, ended up with 3 categories there, 3 strata. And then geographic and climate regions. We took the EPA's ecoregions, which describe actually plant life, but they also have a good correlation with weather and climate. And we divided the state into 4 regions: the Coast Range, the Puget Lowlands, the Cascades, and Eastern Washington. So there's 4. So you multiply that out, and now we're at 24 strata. 2 times 3 times 4. Here's what it looks like on the gray is the urban area. The different colors, we have the 4 regions of the state based on the geography and the weather. And then the little dots are our count sites. And you can see that we have a lot of urban areas in the 2 Puget Lowland and the Eastern Washington region, and very, very few counts in the other 2 regions, which makes sense because that's where most people live. Okay, so we have our 24 groups. We could take the centerline miles for each, compute the AADBT and the AADBPT for each, and then we can get the PMT and the BMT, okay? So this assumes that we have estimates for each segment, and it assumes then that we're taking the average, that we have this representative sample that can be used to estimate what's going on all those segments. So that's a bit of a leap of faith, and if we had a random sample of each strata, maybe we could agree with that, but with the sample we have, that may not be an appropriate method. Okay, the aggregate demand model, here we're also taking the counts, but we're using other variables. So we kept the facility type, the local collector roads and trails and such. We added a bridge variable because Mike Selinger found in the data very quickly that bridges were very high volumes in our data. And so that was just a dummy variable, is it a bridge or not. Population density, we were able to add that. The age, age 18 to 54 or not. Education, does the percent of population with 4-year degree or more, and put that into a simple least squares regression. We could have made a more complicated, maybe negative binomial estimate and negative binomial model, but for the first cut at this, we just used the ordinary least squares regression. And then the back of the envelope method, our National Household Travel Survey, we used some research from Puker et al. And estimated just based on national numbers. multiply it by population. Simple method. We did look at also the Puget Sound travel survey, but because that did not go across the entire state, we stuck with the national numbers. Okay, so results. Our sample-based method, again, I've told you all the reasons to be dubious of these numbers, and we could only estimate for 2 regions of the state, but they were the most populous. So we found trails were highest, biased towards overestimation because we are not sampling randomly. And one of my goals here was to try to get some sense of what was going on, what order of magnitude we should be expecting. So 5,000, 1,500 million miles in those 2 regions, probably on the high side. Okay, so aggregate demand model, we were not able to estimate on the whole state because of some computational problems. Our computers just couldn't handle that much data. So we stuck to one county, one of the most populous counties, King County, and we used all the data and then estimated volumes on all of the segments and multiplied by 365 to get to the estimate of the total for the city, the total pedestrian and bicycle miles traveled for the county, sorry. Okay, and I'll show those results in a sec. Now, the simple back of the envelope to compare to see are we in the right ballpark. We were able to use this method across the entire state, and you can see it's much lower than the numbers I presented for the 2 regions, 700 pedestrian miles traveled, 200 bicycle miles traveled. So big discrepancy, about an order of magnitude difference here between the numbers we're getting from these 2 methods. So to do a good comparison, we were working with Chris Monsieur at Portland State University, professor in civil engineering, and he said, well, you need to compare, so let's choose the county, one county where you can use all 3 methods and see what numbers you get. And you can see these numbers vary quite a bit with the PMT varying from 200 to 2,000. So, and the bicycle miles traveled from like 45 up to 1,000. So again, an order of magnitude difference between these methods. And then just for fun, I decided it would be great to compare this against the vehicle miles traveled. So if we look at our estimates from the sample-based and the national survey-based, we see that we are like 10% to maybe less than 1% of the vehicle miles traveled. So I think we are at least we have defined where the ballpark is, but we need to get a little bit better data before we're going to be able to really pin this down. So we also wanted to compare what we were finding to other studies, and the green here indicates other studies. The blue bars are our research. This is just the bicycle miles traveled, but you can see at the top here, these are the survey methods, and then at the bottom of the graph, the larger bars are the count-based methods, or the sample-based methods, I should say. So the sample-based methods were getting a lot higher volumes than we were predicting with the survey back-of-the-envelope approach, except for this one study that was done in the Twin Cities, that one there in the middle of the graph. And this was conducted back 15 years ago in the Twin Cities in Minneapolis, St. Paul. And they actually got a random sample because they were running the entire study for this specific purpose and not using secondary data as we were. So they had a random sample, and you can see that it's more in line of the bicycle miles traveled per person per day that we would see from and expect from the national survey. So that's both good news and bad. It's good news that we have some relationship there, but it means that perhaps our count data with the bias towards counting at locations where there are actually people walking and bicycling may be overestimating by quite a bit. So this underlines the need to estimate to have better data that's more representative if we're going to use this method. And the very bottom line there, the King County, Washington, that's our aggregate demand model. So you can see it's based on the count data again, so it may be biased toward overcounting, but it is significantly lower, indicating that it is taking into account some of those biases because it has the demographics included. So perhaps a little more accurate there. Okay, so what does this mean? How can we use this information? How can we generalize what we've learned from our adventure in the world of estimating pedestrian and bicycle miles traveled, or trying to estimate it for the state of Washington? So the sample-based method that we looked at is great if you're looking at the facility level, and you counted on that facility, but when we look at the state level, we have these biases that we need to make sure we're accounting for by doing the random sampling, and it's also harder for the pedestrian numbers because pedestrians are less likely to always travel on the specific location you're counting. They like to cut across parking lots, go through alleys, go into buildings, so they're more diverse and a little bit harder to quantify with counting. The aggregate demand model has some pros because it accounts for more things. We're able to take into account the demographics, which is especially useful at the pedestrian level because people are more likely to not stray, to walk closer to their house or their work. For bicycles, though, people tend to bicycle farther from where they live or work, so those demographic variables are not as powerful. And it's hard to get all this data and to implement this at the state level just because of the sheer computational problems, and also it's just a little more complicated. You need a statistical package to use this method, but it did seem to get some more accurate numbers. So we think for bikes, a sample-based method may be more appropriate than for pedestrians. Where pedestrians, it's more important to be getting that aggregate demand model. And all of these can give us data on the facility level, and we can go to the state level from the facility level by summing all those facilities to get to the state level. But this travel survey is really a method that is most useful for the city or state level, and we cannot get down to the facility level with that data. So that's the big problem with that approach. Okay, well, with all these problems, now let's not get too depressed. There is hope and there is progress. So we are improving the count program. The Washington State Department of Transportation is actively improving their count program, and as I said, expanding their permanent counters. And we also want to work with them in the future to remove bias if we're going to use this approach. And then travel surveys, if we could get a larger sample using the National Travel Survey or doing a state-specific survey, that would be useful. And then there are other data sources that we explored in this study that I did not mention.